Hi, in this video I'll be going over your test review for radical expressions and equations. Number one, you're asked to compare compare the work of the two students, Marcus and June, and then decide which one made a mistake and explain where they made a mistake, okay? So remember, when we're multiplying two binomials, we double distribute, or you can use the box if you prefer. So 3 times 2 is 6. So it looks like both of their first terms are correct. Next, remember that when you multiply a term that does not have a radical with one that does have a radical, the most you can do is put one beside the other, so 3 square roots of 6. So it looks like June got that correct, but what Marcus did was he multiplied the 3 and the 6, which was incorrect. Next, we would multiply the inner terms here. 2 times the square root of 7 is positive 2 square roots of 7. And lastly, we've got the square root of 42. So it looks like, and there's nothing we can combine. If we break down 42, we've got 6 and 7, 2 and 3, but nothing simplifies, so this is the most that can be done. So June is correct. So it says determine who is correct. So we need to state that June is correct. And then it says explain what the other did incorrectly by looking at their work and what they should have done. So we can explain that Marcus incorrectly multiplied 3 times the square root of 6 and got the square root of 18, but it should have been 3 square roots of 6. So how would they correct it? Marcus needs to know he can't multiply a number without a radical with a number and a radical. Okay, so you can't multiply a number without a radical with the number that does have a radical, okay? All right, for number 2, you're asked to simplify. I'll have room on your test for you to show your work, but I'll go ahead and do these on a separate sheet. All right, so remember we need to do our factor tree for 108, and because it's a cube root, we need to make sure our answer has cube root. So I'll write that up there to help you remember and not forget, and that you can, you got to look for groups of 3 of the same factor. So 108 is 2 times 54, which is 2 times 27. Nope, 26. Yes, 2 times 27, which is 3 times 9, which is 3 times 3. So really what we're dealing with here is 2 times 2, 3, 3, 3. And then while you probably don't have to, some of you may not have to write all these out, I am. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then again, our index is 3, so we want to circle 3 of the same factors. So many groups we can form. So that means we can have a group of 3s, 1 group of R's, 2 groups of S, and 3 groups of T's. And let's see what's left. 2 times 2 is 4, and an R and an S is left. So that would be our final answer. So write it up here. 3RS squared T cubed cube root of 4RS. All right, for B, got the square root of 50 plus the square root of 98 minus the square root of 27. Remember that when you are adding radicals, you can only add terms that have the same radicand and same index. So we've all got square roots here, but we've got to simplify each one of these. So when we simplify each one of these, we end up getting two expressions that have the same radicand. So that will give us 12 square roots of 2 because I'm adding the 5 and the 7 minus 3 square roots of 3. And then, of course, we grab a calculator, we can check our answer. Please remember to do this on your test. If you type in the problem, hit enter, and then type in your answer, and they match up. So that tells you your answer is correct. Next for C, this will be similar to, now I didn't do box method for, if I can write it right. I didn't do box method for problem 1, so I'll do box method for this problem. Maybe it'll help you. And 35 just breaks down to 3 and 5, both of which are prime. So there's nothing I can do to simplify, so we just want to write our answer with all of our terms. 12 plus, because it's positive, so plus 3 square roots of 5, plus 4 square roots of 7, plus the square root of 35. And of course we're going to check our answer, because if we practice it during the review, we'll remember to practice it or check answers for the test. And I want to make sure you also understand what it should look like when you type it in. Notice after I hit the radical, to get from being under the radical, I hit the right arrow. All right, and they match up. So our answer is correct. All right, next for D. Again, this is multiplying, but we have numbers outside of the radical this time. I think when we did this in class, a lot of you all liked the box method, so I'll use the box on this one. It would just be a 2 by 1 box here. So 4 times 6 is 24, 5 times 2 is 10, then plus 6 times 3 is 18, 5 times 3 is 15. When you break these down, the only factors are 5 and 2 and then 5 and 3, none of which simplify, so that would be our final answer. But of course we should check it. And then our answer, 24 square roots of 10 plus 18 square roots of 15. And they match, so our answer is good. All right, next for E. No adding or subtracting here, but we are multiplying. So I'm going to go ahead and break down well, let me write it first. That's 2 times 6, which is 2 times 3. So it's really 2 times 2 times 3, 2 A's and 6 B's times 5 which is 2 times 4, which is 2 times 2. Because our index is 2, we're looking for pairs of the same factor. Now over here I already have a 2, but then I'm bringing out a 2, and an A, and a B, and B, and B. So that gives me 4AB cubed. Square root of what's left is just my 3. On this side, I already have a 5. I'm bringing out a 2. I'm bringing out 2 B's. What's left is 2, an A, and B. Right there, 2A and B. So times 5 times 2 is 10. B squared, square roots of 2AB. Now I should be able to multiply still what's on the outside. Now you may have gone ahead and multiplied first and then simplified. Either way, you'll get the same answer. 4 times 10 is 40. A, B cubed times B squared is B to the 5th power. And then the square root of 3 times 2 is 6. AB. Now we can't type in all these variables to make sure they're right, but we can certainly type in the numbers. So if I type in 2 square roots of 12 times 5 square roots of 8, and then type in what I got for the answer part, which was 40 square roots of 6, they should match. So they do. Again, I typed in 2 square roots of 12 times 5 square roots of 8, and we get 40 square roots of 6. So just check over and make sure you don't have any mistakes with your variables. All right. So next for problem F, we are combining some terms here. If we can simplify, we need to go ahead and simplify. So notice for F, I have 2 terms with the square root of 10. I have an integer, and then I have minus 15 square roots of 9. Well, we should know that the square root of 9 is 3. So when we take our negative 15 and multiply 3, we get negative 45. That means then we can identify as like terms also these integers here that should be combined. Okay? So if I combine negative 3 with negative 45, and you could just type in negative 3 minus 45, we get negative 48. Now combining these terms, all I do is combine the numbers out front. So 13 plus 9 is 22 square roots of 10. Now 10, if I try to break it down, I'm only going to get 5 and 2, and I cannot further simplify that. But, of course, we're going to type it in our calculator and check our answer. 3 square roots of 10 minus 3 plus 9 square roots of 10 minus 15 square roots of 9. Now compare that with negative 48 plus 22 square roots of 10, and it matches. So minus 48 plus 22 square roots of 10. Okay? All right, next for G. 3 square roots of 7 divided by the square root of 14. Okay? 3 square roots of 7 divided by the square root of 14. Now, if I were to simplify this, I would just get 7 and 2, meaning it does not further simplify. So that means I can go ahead on to my step for rationalizing. So if I multiply by the square root of 14 on the top and the bottom, I get 3 square roots of 7 times 14 is 98. Some of y'all might have seen a shortcut, and that's cool too. And then square root of 14 times square root of 14. Remember, if you ever get confused, just type it in, and you'll get 14. Now, we should always work to reduce their radical if possible. It came from 7 times 14, so I know those are two factors. 7 is prime, but 14 is 7 times 2. That means I could take out a 7. So 3 times 7, square roots of 2 over 14. If I multiply the 3 and 7, I get 21. Then I can reduce this fraction 21 over 14 because both terms are divisible by 7. So 21 divided by 7 is 3, and 14 divided by 7 is 2. So if in my calculator, when we type this in, if we type in 3 square roots of 7 divided by the square root of 14, and then type in our answer, 3 square roots of 2 divided by 2, our answers match. So we should feel good about our answer there. Please remember also, some of you may have noticed that the square root of 7, you could have extended and just simplified this too. So 7 goes into 14 2 times. Then you're left with 3 divided by the square root of 2, and you could have rationalized with the square root of 2. So some of you might catch that, and if you do that, that's great also. And see, we got the answer actually a whole lot quicker. But both of these are correct methods. So our answer was 3 square roots of 2 over 2. All right, and finishing up the last two with the radicals, and then I'll do another video on the equations. For H, notice that in our denominator we have a sum or a difference here, 5 minus the square root of 6. And in this case, we always want to use our conjugate. So 5 plus the square root of 6. We always want to multiply by the ratio that equals 1, made up of the conjugate. So that means when we multiply the bottom, if you need to, guys, this bottom, I'm okay if you put it in the calculator because you will get an integer, as long as you do this correctly. But make sure you put parentheses around this stuff, okay? So 5 minus the square root of 6 times 5 plus the square root of 6, and we get 19. Now, where that comes from is multiplying 5 times 5 and getting 25, and then positive times a negative is negative. The square root of 6 times the square root of 6 is the square root of 36, which equals 6, and 25 minus 6 is 19. Up top, we do not want to just put this in our calculator. If you want to do the box and multiply one term by two terms, that's fine. But recognize you'll multiply this whole term by 5. Since this one has the square root of 2, but this one doesn't have a radical, all we can multiply together are these numbers on the outside. So 5 times 5 is 25 square roots of 2. Then when we multiply these two terms, we keep we multiply the radicands. 2 times 6 is 12. So we're almost done. We just need to go through and simplify anything that could be simplified. Hopefully you recognize that the square root of 2 is made up of 2 times 6, which is 2 times 3. Therefore, it's 2 square roots of 3. So if I just replace that term with this, keeping in mind that this was 5 times 2 square roots of 3, from right here, then I need to multiply the 5 times 2 to get 10. If I don't do that step, I'll mess up. The only way you could possibly reduce is if 25, 10, and 9 all had a common factor, but they do not. So let's check our final answer in our calculator. So our original problem, and I'm going to look back here at H on my paper, was 5 square roots of 2 divided by the quantity 5 minus the square root of 6. So I'm just going to type it in as is, hit enter. Now compare that to our answer. We got 25 square roots of 2 plus 10 square roots of 3. Hit enter and divide by 19. And notice that these two answers do match. Therefore, we know our answer is correct. So h is 25 square roots of 2 plus 10 square roots of 3 all over 19. Keep in mind, though, if you typed in this answer here, it would be equivalent, so you would get the same decimal answer, but you would get it marked wrong because the square root of 12 was not simplified. All right, and last one up here for the radicals. Let's take care of I. We've got 7 minus the square root of 3 over 2 square roots of 8. I highly recommend that you recall that the square root of 8 is equal to 2 square roots of 2. So that means our denominator is technically 4 square roots of 2. Now, you can rationalize using the square root of 8, but then you're going to have to simplify later. So I'm going to repeat the numerator, but rewrite the denominator as 4 square roots of 2.
Report to the front office.
Now we want to rationalize.
Report to the front office.
So I'm going to multiply the top and the bottom by the square root of 2. Only the radical part. Now we distribute the square root of 2 over this term. But for those of you that like to see the box, I'll go ahead and do the box. Alright, so when we multiply these two terms, we get 7 square roots of 2 minus 3 square roots of 6. So that'll be my numerator. And then on the bottom, when we multiply 4 square roots of 2 times the square root of 2, we get 4 times the square root of 4, but the square root of 4 is 2, so 4 times 2 is 8. You could also put that in your calculator because remember you should always be trying to achieve a rational denominator, a rational number in your denominator. So I'm going to type this in, but what we need to make sure we do is every time we have a quantity where terms are being added or subtracted, when we type it in our calculator, we need to make sure we use parentheses. So 7 minus the square root of 3 divided by 2 square roots of 8. And then our final answer, again with parentheses, 7 square roots of 2 minus 3 square roots of 6 divided by 8. Oh, they don't match. Let's see. Oh, I know the problem. When I rewrote this over here, I apologize for this. I rewrote it, but wrote 3 square roots of 3, and it wasn't there at all. So this should have just been 7 square roots of 2 minus the square root of 6. And then the denominator would still be 8. So see how important checking is? It helped me catch mine. So again, if I type in 7 minus 7 minus the square root of 3 divided by 2 square root of 8. And then my answer, 7 square root of 2 minus the square root of 6 divided by 8. Now they match. But that's how important checking is. It helped me to even catch my mistake there. So again, what I messed up on was having a 3 right there. So it just shouldn't have been there. So 7 square roots of 2 minus the square root of 6 there. And that's my final answer. All right, your next video will cover number 3, the equations.